Let's do another stoichiometry problem, sorry. There it is. What volume in milliliters of 0.25 molar sodium sulfate solution is needed to precipitate all the barium as barium sulfate solid from 12.5 milliliters of 0.15 molar barium nitrate solution? This is a stoichiometry problem. The stoichiometry problems always require that we start with a balanced equation. So the equation is written for us, but if we check it, we'll see that it's not balanced, and to balance it, we're going to need to put a 2 in front of there. And if you need to stop at this point, pause and check to make sure that's right, you can certainly do so. But let's go on. Next step will be to use what we're given and change it to moles. So here's what we're given: 12.5 milliliters of 0.15 molar barium nitrate solution. So we're given that. We could either use the definition of molarity, or we could use the fact it's got an of between it, and of means that we're going to multiply. So let's go over here and do that. Well, you may say, well, we need to change the 12.5 milliliters, but I'll show you a trick here so we don't need to change it. 12.5 milliliters times 0.15, and that's big M. But remember, big M is defined as moles per liter. But we could also define it this way: if we divide both moles and liters by 1,000, it'll be millimoles per milliliter. And when I do that, then the milliliters cancel out, and I'll end up in millimoles. So when I do that calculation, it comes out to be 1.88 millimoles, and that's millimoles of barium nitrate. All right, so there's the next step. So the next thing we'll do is we'll use the mole ratio. So 1.88 millimoles, that's an 8 moles of barium nitrate times the mole ratio. Well, on the bottom is going to go barium nitrate. We'll go back to the balanced equation. The number in front of barium nitrate is 1. So there's 1 mole down here. That's actually 1 millimole. Sorry, barium nitrate. Let's keep doing everything in millimoles. And on top goes what we're looking for, and we are looking for sodium sulfate. In front of sodium sulfate is also a number 1. So that's 1 millimole of sodium sulfate. So doing that didn't do anything with change the substance, because we're just going to cancel out millimoles of barium nitrate here and here, leaving us with 1.88 millimoles of sodium sulfate. All right, so we have millimoles of sodium sulfate. Now we need to find out what volume we need. So if we take this and we multiply it, then we're going to do something a little tricky here. If you use the definition of molarity and you arrange that equation, you'll see that what we need to do is take the number of moles and divide it by the molarity to find the volume. So I'm going to take this molarity right here, and I'm going to put it on the bottom, because that means we'll be dividing by it. But remember what the units are. Big M is moles per liter, or as we're doing this problem, it's millimoles, and that's per milliliter, but the milliliters will go up on the top. We invert the fraction and multiply. If we check out the units, millimoles of sodium sulfate cancel out millimoles, we'll end up in milliliters. And that number is 7.52 milliliters of sodium sulfate. If you like, you can also do that problem and convert all of the units and then convert back at the end, and you'll get exactly the same answer.